Hello, greetings. This is our group's paper slide video. For this, we're doing Growth and Decay by Jordan Brady, Maddie Goodwin, Cooper Easton Riddle, and Colby Hopper. Growth and decay represents an increase or decrease over an amount of time. There are two functions. The explicit function, using A as the initial or start value, B as the rate of growth or decay, and X, time. Another is the recursive function. Here it shows next equals now times rate. Now is the initial value. Here is an example of growth. In 1990, Florida's population was about 13 million. Since 1990, the state's population has grown about 1.7% each year. Calculate the population for each year from 1990 to 1994. Here, you have 13 million as the starting initial value, plus 1 for the growth, since 1.7 is higher than 1, plus 0.017 as the growth rate. That is raised to the exponent of x. X is time in years. As you see this graph, it shows in 1994 the population of Florida will have grown to 13.9 million. Here is a recursive equation for the same calculations. Next equals 13 million, 0.1.07. Steps to problem solving. Your situation will distinguish if your equation will be growth or decay. Yes. Now, this is an example of decay. Since 1980, the number of gallons of whole milk each person in the U.S. drinks in a year has decreased 4.1% each year. In 1980, each person drank an average of 16.5 gallons of whole milk. Calculate the gallons of milk for each year from 1980 to 1984. Here you see 16.5 as the initial value. 1 minus, instead of adding 0.041 because it's decaying. X, the time in years. As you look at the graph, it shows 1984 has been decreased to 15.6 gallons of milk. The recursive equation, similar to the one we just showed you, is next equals 16.5 as the initial value times 0.041 as the decay rate. Now, you might be wondering, how does these equations relate to the real world? As you see right here, there's a family tree. Population growth, you may find yourself a nice lady friend, have kids, your kids may have kids, and the population will grow. Also flowers. You may plant 4 flowers in 2013, but you may only plant 3 in 2014. Flower decay. Some may die, some may grow. Yeah, it happens. Reviewing what we just said in our paper slide, the explicit function, the start value, growth decay rate, and time is shown in this equation to find specific solutions. F of x, also known as y, equals ab raised to the power of x, which would be the time in years. Recursive, simple version of an explicit function that shows your value to plug in. Next equals now times rate. The now is start. And the growth is or decay is the rate. The end.